Alright, here we are with my UI design mockup of Snacklebot. I'm going to break this into 3 parts because it's hard to record this game screen and then the overall layout and then the backend code. So we'll start with the game itself. This is the main menu screen. Here's a play button, options and quit. Hitting the quit right off will actually bring off the quit confirmation. So you can hit yes and it will actually close down the game, or no, it should bring it right back. Options mode is the big, heavy-duty UI of this particular menu area. There's a difficulty. These buttons will actually change the difficulty. There's 4 modes, and it can flip back and forth. When it gets to the last one, it'll go back to the start. The volume slider also shows the amount of volume. It doesn't actually affect the volume, it's just an example. The tutorial, on the other hand, and these checkboxes don't do anything. They're just also examples. The tutorial, however, does. We're going to check off the tutorial for the moment. Go back and go and play the game. Right away, you can see I added a nice camera transition to start the game. This lets me actually put my character anywhere at any level as I want, and it would give me like a nice intro menu that just evolves into the game. The movement controls are like how we actually created them inside of class, so mouse hold to move, and the little guy moves around. This button over here on the side is the pause menu. The pause menu also has some options but does not have difficulty. The tutorial box will check and uncheck. It links to the main menu's tutorial box. So if you uncheck the tutorial in the main menu, it'll uncheck the tutorial here. The volume slide I did not link, but I could probably. But for now, for just demo purposes, it works the same as in there, but it's just a mock-up. Now if we go back, and we go back to resume, the quit here also brings up the same quit game dialogue. If we go back to resume now, you'll see that there is a tutorial here, and it's just basically a big pile of text. I tried to get it to look nicer and more formatted, but it was kind of difficult. The tutorial, I can hold mouse button to move, collide with orbs to collect them, find all the orbs to win. Pretty simple. And of course, go back, uncheck the tutorial, resume, it's gone. Now, there's an orb progress bar here. Initially, I was going to only have it be the orb progress bar. However, I thought it was a little too vague to tell how many orbs are actually in the map, so I added a counter at the bottom of it too. But I still like the progress bar, and we'll go into how that goes. Hitting the orb will create a sound effect, and will mark progress. The more orbs you actually collect, I set it up so that it actually increases the pitch of the sound effect based on how many orbs you have actually grabbed. So the one issue with the movement we have set up is overhead areas, overhead objects like this make the actual pathing a nightmare. But we ended up getting it. It actually kind of becomes a gameplay challenge in and of itself. Now I do have a victory screen, so we're going to run around here and collect all the orbs real fast. If I remember where they all are. The landscape I made just a little forest out of. I did so much UI work I didn't want to go too crazy with the level design too. If I keep this and I make this something like more collectathon style game, then I'll obviously put more work into the game development itself. Or the level design itself rather. One more, I think it's usually over here. Maybe we'll find it, I'm sure. I think it's up here. The last orb's always the one I get screwed up on. I don't have my speed run running strat for my own game yet. Shoot, where'd it go? There are borders around, hilly borders around the area. The music itself is a free loop that I found on Pixabay. I edited it out to get rid of the ending, and right now it's just a looping MP3 that will start up as soon as the main game starts. The sound effects of the orbs are created at the location of the orb in order to try and make a bit of a 3D sound. It doesn't last long enough to actually go. And here we go! The last thing I was going to say before I finish this is I was going to try footstep sounds. They're a bit too involved, and since they're kind of out of the scope of the project, and I feel bad for turning this in a little late already, I decided to not pursue that. But okay, as we get the last orb, we got a nice victory screen with material, and we'll see you in the next part. So, as I was saying in the gameplay portion, the victory screen is a material, and it's a UI material. It will make the confetti just rain down infinitely. It's pretty cool. This is the overall UI level here. It's not anything super wild, it's just kind of what I put together in school. And I added the forest part. Just to give it a little bit more depth, but like I said, the forest trees kind of make pathing really difficult. If I was to make this a full-fledged game, I would probably change the movement control scheme, or find some way that like other overhead games do, where they use like a way for the camera to clip through so you can see underneath. But that is all for this particular section, just showing the level. We will get to the back end in 1 second. Alright, we're going to get meta with this, because I recorded a half an hour of footage only to realize that my mic was off and not running. So we're going to go through this video that I set and commentate on it. So right here, this is the main UI menu for StackleBot. I'm sure I'm stuttering in the actual real world, or whatever it is I do. Basically, StackleBot has, or my UI setup has a bunch of nested UI elements, UI widgets. There's the main menu folder, the title overlay. Those are basically the main menu of the game. The StackleBot has a animation that we just put on it to help it go, and it just loops on start. What else am I saying here? Oh, going into the basically this is the modular button. It is basically just a big button and big text fully filling out the canvas space. It also has the animation that we do, and yeah, all this on pre-construct is just being exported out, so you can edit and modify it in the editor. There's the animation, and when you click on text, there's the text animation name, and it just does the same thing basically as the main menu title screen animation. So all of those are in essence the modular buttons with various texts and textures applied to them. All the textures I made in Blender. I made basically the buttons in 3D and the different UI elements in 3D, put them into a rendered scene with lighting and rendered them out. That way they look a little 3D, that way they all have a similar lighting style to them. So let's see, I think we're going into the options canvas. This was big difficult part of the of the main menu, mainly because of that difficulty chooser. And we will show you why here in a second. I made good use of the full screen anchors mode. The full screen anchors mode lets you just sync up all of the different nested UI elements so they all fit together and the same. There are checkboxes that I discovered as components for UI elements, and they basically have a checked and unchecked state. None of my checkboxes do anything. In this tutorial we saw, or the gameplay we saw the volume slider, and difficulty we saw the volume slider. We'll get into how that difficulty works in a second. Other than the options canvas, this is the main user interface, and this is what I mean by its nesting widgets, because this is the main UI for Final widget, and it now has the quick confirmation and the user HUD widget as part of it. We'll get more into the quick confirmation, how it works. The UI, the user HUD widget, which is what we're going into now, shows all of the this basically the gameplay widget. On visibility change is what we use to control a lot of the nesting of the UIs. I think I'm going to start up at the top here if I remember what I did. What am I doing here? But yeah, on visibility change basically shows how the user HUD saves or switches over, and we'll get into that in the future, what is actually going on there. Starting at the top here, I forgot what this did, and I sat there for a hot minute trying to remember, and nothing came about it. I still don't remember what it does. It's probably code that doesn't actually work. It was just something I was trying to do. It's fine. And the startup, a lot of these are very similar to what we did in the tutorial, or into the classes. This starts the animation for the StackObot text, and it will make sure that the options canvas is hidden on startup. The quit game button will bring up that quick confirmation widget that we showed you earlier and hide the other widgets. The option button, the same thing as we usually did in class, hides the menu and the title, brings up the options canvas. The back button does the opposite of the options button and hides the canvas as well as that. The volume adjustment, do I get into this now? I forget if I got into this now. But basically when the volume slider is, when the change is detected in the volume slider, it will set the amount to this volume variable. And here, to get the text of the, right there, the volume text that shows how much volume there is, we pull that volume variable out, we multiply it by 100, and then we change it into a text field. In this text field, I formatted it so it only shows one fractional digit. That way it doesn't have like a million digits when it tries to format the text out from a float. So that's all for that. That controls that. Where else are we going here? The difficulty. The difficulty is... Oh god, I gotta explain this again. Okay, the difficulty controls when either the forward or the back button are pressed. It will set the difficulty index. Now the difficulty index is basically a pointer controlling which index we're currently using in this string array. String arrays are basically a list of strings, and you need an index. to tell the output which string in that list you want to show. So in essence, on top here, when you hit the back button, it subtracts the index, and when you hit the forward button, it adds. On the back here, we check if it goes underneath 0, because the indexes for the string array can't go under 0. So if it goes under 0, it will then use the string array to find the last index, or the final index, in the string array. And instead of being -1, it will instead set the index. It will set the difficulty index variable to the last index of the string array. This is probably where I'm explaining about strings. Now, after we set that last index variable, as you can see up here, we will then use that index to get the text variable that is stored in that index and convert it into an output text. And then, of course, if that condition in the branch fails, it doesn't worry about the set. It just takes the number that the difficulty index is at, gets the string variable in it, and sends to output. I really wish I had actually recorded this audio. And down here it does almost similar, where we use the last index to check if, when adding, if the difficulty index variable goes greater than that last index. And if it does go greater, and it goes to true, you can see we set that difficulty index to 0, because 0 will always be the first spot in any array. And then we get the spot at 0, turn it into text, call it. Otherwise, we just get the spot here that the number is currently at, turn to text, call it, or set it. The play button. Oh gosh. The play button will hide everything out. It will show the user menu, the user HUD. And then we will set the player's input mode so that we can actually control it in the game. We will then cast this and do this custom camera transition function that I created. And now we're going to pop over to the bot blueprint here in order to show you what that does. And this is a big mess of things we'll get into in a second. This is my little camera, my little bot, my main character basically. His camera's up there, and essentially we moved that camera to a different position when the game starts. So as you can see, there's the camera start position, and then that's the in-game position that I highlighted the camera pose variable. There's also rotations associated with them, the starting rotation and the camera rotation. Respectively, that's. And the game startup, we set that camera to the starting position and rotation. And now, this camera transition from the menu basically does this camera call event. That's all it does. I tried to call it directly, I don't think it worked. But it worked through the function, and that's all I got. So when we call this camera event, we essentially just start a timeline here. The timeline is a really simple timeline, and it controls the lerp functions. There's a lot of explanation that I unfortunately didn't record on what a lerp is and how it works. Essentially, it transitions a value from A to B over, and then the alpha shows at what percent of the way the transition from A to B is. So 0 to 1 is basically going from, from A to B, 0 to 100%. So in this timeline, and it's really just what we do. It's over the course of 5 seconds. So 0 at 0 seconds and 1 at 5 seconds is all we need. And back in the event graph, it takes that, and every update, it will take those outputted numbers and set the new location and rotation of the camera object. And that is what creates the smooth transition from the main menu, from the start game menu, to the gameplay. Down here, this is my attempt at making footstep sounds. It did not, it worked, but I didn't like how it sounded. It sounded too rhythmic, and it just didn't sync up with movement stopping very well. I could probably have messed with it more. I'm sure there's a better way to do it in general. Basically, it's similar to how we got the transition between the walk and run animation going. And then from there, we check if there's any motion at all, and we also check if this footstep variable is, or footstep boolean is false. If it's false, here, then we go through, we play the sound, and we set it to true, and then wait a small moment and set it back to false again. And that way it wasn't playing at like 60 times a second, because I was using this on the event tick to check, which was probably one of the reasons it sucked. Let's see where else I go here. I'm sorry, I'm drinking water. My voice is now like strained. Next UI menu I went here. This is for when you will get into the quick confirmation. Just note that when the quick confirmation hides itself, it shows the other things. It shows the other options, similar in the user HUD as well. This is the tutorial setup. I'm not sure if we're getting into the tutorial right now. Watch if I did. Yeah, okay. So this tutorial checkbox, you can basically check if there's a state change. And what we did in order to make sure that the tutorial variable was saved between the start menu and the gameplay was we saved a boolean in the player character called tutorial showing. So that way, when the start menu was turned off and the gameplay started, aka when the user HUD visibility changed to true, it checked our player character for if that boolean was set to true, and when it was true, it will call for the user HUD, and it will call for the tutorial overlay button in the user HUD. Let's see if it will call the tutorial overlay button in the user HUD, and if that tutorial showing variable is true, it'll make the tutorial visible. If not, it'll make it false, or make it invisible, rather. So it's just what I'm showing now with far more clarity. It's easy to describe on something you already showed. I feel like a practice session. So this is the user HUD widget itself. On the pre-construct, we hide the victory and pause screen. The music starts. The pause menu is very similar to what we made in class. We use the P key or touching the menu button, which is that button right there in the corner that I highlighted. There's also that release call event that we will get into down there, because that comes from the pause menu widget. But yeah, basically it sets the game pause, shows the pause menu true, and hides everything. And on that release call event, we unpause, we set that hidden. We don't unhide the tutorial, because we have to come down a little ways. On the victory, when the victory state changes, when the visibility changes on the victory screen, it will pause the game, play the victory sound, wait 6 seconds, and then quit game. This is why we didn't unhide the tutorial automatically, because we have to check if that Boolean option on the player is set to true. Because if it's not set to true, then you're not going to want to unhide the tutorial anyway. But if it is set to true, then you do. On the pause menu here, this is the pause menu. There's options canvas. It's similar to what we did in the start menu. I basically copied and pasted it. Hindsight, I should have made it its own widget, but that's okay. It still works just the way it is. Let's see what I can do here. Okay, going to the graph and going all the way to the top. On construction, we just hide the canvas, the options canvas. This does that release call that we talked about back in the UI menu to unpause the game. Yeah, this is just that release call that I mentioned earlier on. And this is how you unpause the game. Basically, I didn't want to put an unpause in a new area. Options button, similar. This will check if we need to have the tutorial checkbox checked or unchecked. So we always have to cast to the player character basically just to check if that Boolean is set or not. The back button works like the other one in the main menu. Just hides the options canvas, shows everything else. The volume display works exactly like it does in the start menu version. So we won't go into that. The quick confirmation brings up the quick confirmation widget, hides everything else. And then when the quick confirmation is hidden, it shows everything else. And then this here, the top checkbox, is state changed. It will update the player character. Oh, I hope my audio didn't just go out. I just heard a weird pop in my microphone. That's the tutorial widget. I found that there's a component called Scalebox, and it really helps to make text fit within a space that's nice and formatted. And I'm about to grab that to show off the scale box, and I'm going to destroy the scale of my tutorial widget inadvertently, because apparently you can't undo that particular operation really well. So, good job, me. Okay, after I'm done messing with that, I think I'm going to try and go to the user HUD to save it. Yeah, and as you can see, I destroyed it. The objectives is just a mock-up of objectives. If it was going to be a fully implemented game, we would have it be a fleshed out UI where we had objective events and we could plug those events into that checkbox. But it's just a mock-up, and here, let me try to save my tutorial widget. More, you can see how the scaler works on that. It's cool that it works nicely, but yeah, it's a little finicky. Actually, a lot finicky. Where do I go from there? Overlay. I should have shown the victory UI. I kind of forgot to, but you saw it during the actual gameplay portion. It's really straightforward, and how it's handled is you already saw. This is the quick game confirmation widget. Basically, when you hit the S button, it quits the game. When you hit the No button and on event construct, it will hide itself. And that's how we actually do the unhiding of the other options later, because the quick game widget hiding is handled here. The only other thing we didn't go through is the goal orb, I believe, and we're going to go through that in a hot second. Yeah, the goal orb. So the goal orb is just a cute little mesh I made in Blender. It really did not take long. It's not that hard to do, and it's not that complicated looking either. It's kind of cheesy looking actually. It has a rotator on it, just like we did in class for making the other collectibles. It's a quick little event graph here. We use the onComponent hit to detect when the player collides with it, but we also do something else very important that I'm going to get into right now. When the game starts, or when the level starts rather, each orb that is in play will send a update to the player character, and it'll basically increment the orb maximum for the player character by 1. That way, at the start of every game, you can have a variable amount of orbs, and each orb will tell the player character how many are in the level. This lets the progress bar work, and this lets the text that's under the progress bar work as well. We will show those off in a minute here. This is the on-collision event. We check that. We increment the orb count here. And then we grab the orb max also, and we do a little bit of... I'm waiting for me to move forward a little bit here. We play the sound. We do a little bit of fun division, that little equation down there, to help raise the pitch every time an orb is collected. So that's how that's working. It basically gets the division and then adds a little bit 0.8 just to bump the actual pitch up. And it works really nicely. It also spawns the sound at location instead of just plays a sound, because that way the sound can exist after the actor is destroyed. I think we're going into the progress bar. We're going into the text under the progress bar, and I'm going to show that off here in a second. Yeah, so it's basically that 0/0 right there. So you saw it on start when the orbs incremented the orb maximum. We take this, whenever that variable is updated, we take the orb count to the maximum, and then append it, turn them into strings, and append them to say A/C, A/B/C. Convert that into a text output, and then return that back out. This is the percentage, this is the progress bar function. Again, it's kind of similar. Yes, we know what this is. Just showing that setup again. But we get the progress bar. When the percent changes, it gets the count over the maximum. And then we check if it's greater than or equal to 1. Essentially, it's got to be 1. It'll just end up being 1 when you collect everything. But I made it greater than or equal to just for floating point error reasons. If it is greater than 1, it'll trigger this victory function, and either way it will return the output of the progress bar back. The victory function just displays the victory screen. And that's this function again, where it's unchanged, it will do the sound delay game. I believe that is pretty much all I have on this one. Sorry the audio in the initial one got screwed up. If this seems weird or funky, sorry. was really annoying to record for almost half an hour only to find my audio was screwed up or didn't record. Either way, have a good one. Let me know what you think. Post-mortem, this is the victory widget. I decided to just show it off real fast here. The victory itself has a similarly working animation to the title screen and the mouse buttons. This image is a confetti material, and the confetti material you can see is simply this image with a banner on it. So even though it's pretty simple, I wanted to just show it off anyway. And then the graph, really it's just on the construct it plays. The handling of the actual victory itself is handled in all of the other widgets that you saw earlier. That's it, just a small update. There you go.